Hello everyone and welcome once again to this coverage of triangles class 10th. We are in the concluding parts of the chapter. So in last video we discussed about the Pythagoras theorem and its converse. Pythagoras theorem is applicable to the right triangles. Okay, we can sum up the theorem and its expression as this: h is equal to under root b square plus b square, and we'll apply this according to the need of the question in this exercise 6.5. So let's begin with first question of the exercise. Now here we are given the sides of a triangle. We have to verify whether it's a right triangle or not. In case of right triangle, we will write the length of its hypotenuse. So let's quickly recall the inequalities of a triangle we studied in class 9th. It goes like this: that in a triangle, the sum of two sides of a triangle is always larger than the third side. One. Second, the angle opposite to the larger side is greater than the angle opposite to the shorter side, and vice versa. When side opposite to the greater angle is larger, and side opposite to the shorter angle is shorter. Okay. Now in a right triangle, the largest or the highest angle is of degree 90. Out of three angles, the highest angle is of degree 90, means right angle is the largest angle in the right triangle. So the side opposite to it will be the longest side of the triangle. Okay, we'll apply the same in here. Now to check whether the triangle is right or not, we'll use Pythagoras theorem that in a right triangle, square of hypotenuse is equal to the square sum of the square of other two sides. Now since hypotenuse is the largest side of the right triangle, so we'll take the largest side. Now see, the first one is 7 centimeter, 24 and 24 centimeter. Out of these, 25 centimeter is the longest side. So if the triangle is right triangle, it is the hypotenuse of the triangle. We will verify it by squaring it and also squaring the other two sides and adding them and see whether they are equal or not. So now 25 square gives us 625, and also 7 square is 49, 24 square is equal to 576. When we add 7 square plus 24 square, it comes out to be 625, means 25 square is equal to 7 square plus 24 square. Square of the larger side is equal to the sum of the square of other two sides, which implies that this is a right triangle, and the length of the hypotenuse is 25 centimeters. So this is the way how we check whether the given triangle is a right triangle or not. Okay, we'll take one more part of this second part. 3, 8 and 6 centimeter are the sides of the triangle. Longest side is 8 centimeter. We'll square it. It is 64. Other two sides are 3 centimeter and 6 centimeter. We'll square them and add them. It comes out to be 9 plus 36, that is 45. Now see, 8 square is not equal to the sum of 3 square and 6 square, which means this is not a right triangle. Okay, so this is how when sides are given, length of the sides are given, we'll determine or we'll verify whether the triangle is right triangle or not. Okay, the remaining two parts you'll do yourself. Let's move to next question. Okay, in this we are given a right triangle PQR, which is right angled at a P, this way. Okay, and M is a point on this QR, such that if we join PM is perpendicular to QR, this way. We need to show that PM square is equal to QM into MR. Okay, now in triangle PQM, this triangle PQ and M, this triangle. In this triangle, by Pythagoras theorem, PQ squared, hypotenuse square is equal to PM square plus QM square. Or by rearranging, writing the expression for PM square comes out to be P square minus QM square. Let this be our equation number 1. In PMR, this in this triangle, PMR, this triangle. Okay, in this triangle, again by Pythagoras theorem, we can write that PR square is equal to PM square. PR square is equal to PM square plus MR, PM square plus MR square. When writing an expression for PM square, it comes out to be PR square minus MR square. Let this be our equation number 2. Now, if we add 1 and 2, what we get? Now see, we need PM square on one side. So adding 1 and 2, we get 2 twice of PM square plus PM square. 2PM square is equal to PQ square minus QM square plus PR square minus MR square. Further simplifying it, opening the bracket, positive ones PQ and PR square minus QM minus MR. Now see, PQ square plus PR square. PQ square plus PR square. In this triangle PQR, it gives out that it is equal to QR square. Replacing this by QR square. Again, QR, see, QR is equal to QM and MR. QR is equal to QM plus MR. So, replacing QR by QM plus MR in the expression, we get this 2m square. Now, QM plus MR square, A plus B whole square is applied to this part. Get QM square plus A square plus B square plus 2AB. Okay, minus this QM square minus MR square. Now see, QM square and QM square cancels out. Similarly, MR square cancels out. We are left with 2PM square is equal to 2QM into MR, or PM square is equal to, transposing 2 to this side, it will be divided, 2 cancelled by 2, and we are left with PM square is equal to QM into MR. Hence, this is proved. So, let's take next question. Question number 3. Here we are given ABD right triangle, ABD, which is right angle at this A, and AC is perpendicular to this hypotenuse PD. We need to show certain things one by one. We'll show this. So first of all, let's take this triangle ADB and ADB, this and CAB, these two triangles. Now clearly, in this one angle is common, one is of 90 degree, so they will be similar by angle similarity criterion. Okay, BAD and BCA both are 90 degree. ABD, CBA, common angle. So these two triangles are similar by angle similarity. So their corresponding sides will be in same ratio, proportional. AB upon CB is equal to DB upon AB, or AB square is equal to CB into DB. Okay, so this first one is proved. Now let's move to second one. In triangle CBA and CAD, CBA and CAD. Now see, in these two triangles, if we take this angle as x, this angle CAB is equal to x, then this will be of 90 minus x. This is 90 degree. By angle sum property, these two angles will add up to 90 degree. One is x, second one will be 90 minus x, like this. Also, this angle in this triangle, whole triangle, this is 90 degrees, so this plus this will add up to 90 degree. This is 90 minus x, so this will be 90 minus this angle. This is x. This angle is equal to x. CDA, this angle is equal to 90 minus CBA. CBA is equal to 90 minus x, so 90 minus 90 plus x, that gives us x, and CAD is equal to 90 minus x. This and this is equal to 90 minus x. Now see these two triangles, we get one angle is of x, one is 90 minus x, and hence they are similar by angle similarity. So their corresponding sides will be proportional. Now what we need to prove, what we need to show, AC square. So we need AC in numerator and AC in denominator on right hand side, then only it will be AC square. So AC upon DC is equal to, we need AC here, AC, right? So AC BC, which gives us AC square is equal to BC into DC. And second one is proved. In third case, we need to show AD square is equal to BD. So we'll take two triangles DCA and DAB. Again, one angle is of 90 degree. In both the triangles, one angle is common. So they are similar by angle similarity. Hence their sides will be proportional. AD upon DB is equal to CD upon AD. Further, AD square is equal to BD into CD. Hence third one is also true. So this is quite easy actually. We just need to focus what we need to prove here, or but we need to show AD square, how we can AD square by the proportions, right? One time it should be numerator one and denominator, when cross multiplying it will get squared. So keep these things in mind and proceed accordingly. So next move to next question. Question number 4. In question number 4, we are given an isosceles triangle which is right angle at C. Isosceles triangle with two sides of equal length this way. So hypotenuse is the largest, means these two sides are equal, AC and BC are equal. We need to prove that AB square is equal to twice of AC square. So very simple question actually, it's simplest of the exercise, right? By Pythagoras theorem in right triangle, this hypotenuse square AB square is equal to AC square plus BC square. Okay, now we are given that BC and AC are equal, so we need to twice of AC. So we'll replace this BC by AC and we get AB square is equal to AC square plus AC square, that is AB square is equal to twice of AC square. Hence it is proved, right? Okay, sixth question. In this question we are given equilateral triangle, a triangle with all the sides of equal length is equilateral triangle. Let ABC is an equilateral triangle with each side equal to 2A. Okay, we need to find each of its altitude. This is the property of the equilateral triangle, that all the sides are equal, all angles are equals, and all the altitudes will be of a same length. So we'll need to find just one. Let AD be the altitude. This is the altitude. Altitude is the perpendicular drawn from the vertex to the opposite side of a triangle. So this is the altitude AD. We need to find AD, and we'll apply Pythagoras theorem to the same. Since altitude is also made of the equilateral triangle property, we can prove these two triangles congruent, right? So since altitude is also median of the equilateral triangle, means this will divide this BC into equal parts. Will half to A, it comes out to be one part is A as well as other part is also A. So we can take this right triangle. In this we'll apply ADC, right triangle ADC. We'll apply Pythagoras theorem and we'll see this AC square is equal to AD square plus DC square. Replacing the values, or we need to find AD square. So AD is transposed to this side. AD square gives out to AC square minus DC square, which further on replacing the values we get AC is 2A and DC is A. So 2A square, that is 4A square minus A square, that comes out to be 3A square. Further, taking square root on both sides, we need to find AD, not AD square. So AD comes out to be under root 3A, right? So each of the altitude of an equilateral triangle is under root 3A, where A is the half of the side of the triangle, right? So let's move to next, seventh question. In this question, we need to prove that the sum of the squares of the sides of a rhombus, quite later, all the four sides are equal. Okay, so prove that the sum of square of the sides of a rhombus is equal to the sum of the squares of its diagonals. It's easy but lengthy question, a bit of lengthy question. So let ABCD is a rhombus and AC DB are its diagonals. Now, since we know that the diagonals of the rhombus, they perpendicularly bisect each other, perpendicular bisectors of each other. Okay, so this is how, given that ABC is the rhombus with diagonals AC and BD, to prove that sum of the square of the sides means AB square plus BC square plus CD square plus AD square is equal to AC square plus BD square. This need to prove. So since diagonals of the rhombus are perpendicular bisectors, therefore AO is equal to this, AO is equal to CO. Similarly, BO is equal to OD. So in triangle AOB, this right triangle, this AB square is equal to this square plus this square by Pythagoras theorem. This is, let this be our equation number 1. Similarly, in BOC, this triangle, this triangle, this triangle, we'll apply Pythagoras and see what we get in all the triangles. This triangle we get BC square is equal to CO plus CO square plus BO square. In this triangle we'll get COD triangle, we get CD square is equal to CO square plus OD square. And in AOD triangle, by Pythagoras once again we get AD square is equal to AO square plus OD square. So these are the four equations involving four sides of the square of the four sides of the this rhombus, right? So let's add them. On adding, we get on left hand side AB square plus BC square plus CD square plus AD square, right, is equal to, on right hand side, this AO square plus BO square plus CO square plus BO square, all this. Now we'll apply this. AO is equal to CO and BO is equal to OD. Let's see what we get. Now in this, if we simplify, we get twice AO plus AO, 2AO. Similarly, twice of BO square, twice of CO square, and twice of OD square. 2 is taken outside the bracket. Within the bracket, we are left with this AO square plus CO plus BO square plus OD square. Now again, AO is equal to CO. So CO can be replaced by AO. Similarly, OD is equal to BO can be replaced by BO, which further gives us that twice of this, twice of AO square, that is twice of a BO square, that is 4 AO square plus 4 BO square, twice of AO square 2BO whole square. Twice of AO is equal to AC and twice of BO is equal to BD. Right? So this is equal to this. AB square plus BC square plus CD square. This AD square is equal to AC square plus BD square. Hence this is proved. Okay, so we are taking the important questions of the exercise. This was the first part. Remaining important question will be taken up in the next part of the exercise 6.5. So till then, keep your mind full of positive thoughts and keep practicing for the achieving your goals. Okay, because your future is created by what you do today, not tomorrow. And thanks for watching. Thank you.